Let's jump right into this explainer. You know the ultimate paradox right now? We're constantly told to speed up, to adapt instantly, to be an AI native like yesterday. But what if the real secret to surviving the AI revolution is actually slowing down? What if it's ditching the digital tools completely? Today, we're unpacking a perspective that absolutely flips the script on how we should be learning in the modern world.
I mean, think about it. Why calculate by hand when AI can do it instantly? It's a totally fair question, and it gets right to the heart of the modern learner's dilemma. When you can get a perfect answer from a chatbot in 3 seconds, doing things the hard way, like spending an hour mapping an algorithm on paper, just feels totally backward. It's so tempting to just grab that output and run. But as we'll see, we're skipping a crucial step in human cognition when we do that. University of Colorado Boulder computer science professor Tom Yeh hits the nail on the head here. He points out that having the answer doesn't mean you know it. He really challenges us with this idea of ownership. Because anyone can copy-paste a prompt, right? Anyone can print a certificate, but actual ownership of an idea, that only happens when you've personally wrestled with the material yourself. And what's really cool is that Professor Yeh isn't just saying this from some ivory tower. He lived it. He shared this incredibly vulnerable story about his own career. He specialized in older machine learning models, things like support vector machines. Well, by the time he became a professor, the deep learning wave had crashed over the industry, and he had entirely missed it. He was suddenly the old professor. He literally had to painstakingly relearn modern AI from scratch just to keep up with his own students. So how did he catch up? He didn't just fire up the newest coding environments. Actually, his biggest aha moments came when he tossed the digital shortcuts completely out the window. He physically drew out the math and algorithms by hand, on paper. Take AI transformer models, for instance. To figure out how they process sentences, he'd draw little boxes for individual word tokens and physically write the exact numerical values inside them. By patiently mapping it all out by hand, this massive, intimidating AI mystery just dissolved into something he could fully grasp. He believed in this so much that he took a really radical step in his own classroom. He taught an entire semester of C++ programming by writing code out on a traditional blackboard instead of live coding on a screen. Why? Because it forced every single person in that room to learn at a deeply focused, humanly possible speed. He couldn't teach faster than he could write, and his students couldn't learn faster than they could follow. Plus, if a student is physically writing notes in a notebook, their hands aren't on their keyboards checking Instagram. The distraction just vanishes. Let's zoom out for a second and look at the broader timeline here. Tech trends shift incredibly fast. In the 90s, Jurassic Park comes out, and CGI is the absolute must-have skill. Then, boom, it's big data. Then, machine learning. Today, everybody's talking about generative AI tools like Claude or DeepSeek. Tomorrow, it'll likely be quantum computing. If your entire strategy is just learning the interface of today's hottest tool, you're going to be exhausted and honestly obsolete the second the trend changes. But here is the absolute game changer. Underneath all of those massive, fleeting shifts, from the CGI dinosaurs in Jurassic Park to tomorrow's quantum computers, lies the exact same foundational math: matrix multiplication. It's the evergreen foundation. If you understand the core math making these systems tick, the surface-level tool changing every 2 years doesn't matter. You are completely insulated from the tech treadmill. To put that into a really vivid historical perspective, think about South Korea's stunning Gyeongbokgung Palace. Tragically, this beautiful structure was completely burned down in the 1500s. The walls, the roof, the art, all gone. But beneath all those ashes, its solid rock foundation remained entirely intact. Because that evergreen rock foundation was still there, centuries later, architects could beautifully rebuild the entire palace. It's the exact same thing with your skills. A foundational grasp of basic knowledge lets you effortlessly rebuild your career when current AI tools become obsolete. If you only focus on the shiny new tools, the roof of the palace, so to speak, you'll have to build a brand new house from scratch every time the tech landscape catches fire. So we really need to redefine what we're even doing here. True learning isn't a certificate you buy. It isn't the digital artifact a prompt generates for you. It's the willingness, the patient, deep effort to actually open up the black box and take on a challenging task. The friction you feel, that is literally where the value is created. This totally reframes how we should view our childhood experiences too. Professor Yeh points out that skipping the latest trending AI tool is totally fine. A new one is coming next month anyway. But skipping foundational practices like childhood piano lessons or soccer drills, that actually damages your long-term character. Because practicing piano or chess wasn't just about the music or the game. It was about building the transferable patience and resilience you need to master anything difficult. Think about the mindset that builds. It tells your brain, there was once upon a time I tried hard. I was successful. So next time I can learn this too. What you truly retain from slow, foundational, by-hand learning isn't just the memory of an equation. It's this enduring confidence that you can conquer any complex topic thrown your way. You're building evidence to yourself that you are capable of doing hard things. That is a meta skill no AI can ever replicate. Sadly, we're seeing the absence of this foundational mindset all over modern education. For years, teachers battled websites like Chegg where students just shared answers. When AI arrived, Chegg's business model collapsed, and educators were thrilled until they realized students just started using AI to cheat instead. Why? Because actually, AI and Chegg are just symptoms. The real disease is an incentive system that values the final output way more than the slow, difficult process of real learning. And this reveals a massive disconnect between the classroom and the real world. Employers aren't actually looking to hire AI natives who only know how to prompt a chatbot. They are desperately hunting for people with the exact character traits forged by slow, difficult learning, problem solvers, team players, folks with strong work ethics, and excellent communicators. Because, and this is a key takeaway from this explainer, AI adoption is the byproduct, not the cause of a good worker. If you hire a genuinely dedicated problem solver or team player, you don't need to force them to learn AI. They're going to naturally pick it up on their own to get the job done. AI won't make a selfish worker a team player, but a good team player will use AI to help the whole team. Ultimately, we are left with this perfectly provocative thought from Professor Yeh. AI cannot change people, but you can change AI. What foundational by-hand knowledge teaches us is that technology can never, ever replace human character. Your patience, your focus, your willingness to learn at a human speed, that will always dictate how you use technology. So I'll leave you with this. Are you just chasing the latest digital shortcut, or are you taking the time to build a solid rock foundation that will last a lifetime?